The standard form is the method where scientists or physicists use to write very large or very small numbers. It looks like this. Some number times 10 to the power of n. And the number is always between 1 and 10, inclusive of 1 but less than 10. You have a number like that. This is a little bit confusing. If you were to take one look, you are unsure exactly how small the number is. But if I were to rewrite it into the standard form, it will look like 1.37532 times 10 to the power of 1, 2, 3, 4, 5 minus 5. So with practice, you will know that there are 4 zeros in front of this number. Now this is the same for very large numbers, such as this. So you're not quite sure how many hundreds of millions or how many billion is this, unless you count. But if I were to write it in the standard form, it will look like that. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So straight away, you know that there are 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you know that it's 7.8 billion. How do you convert a number into the standard form exactly? Now you start off with the smallest number. So for example, you have 13. Now 13, if we were to write it in the standard form, it would be 1.3 times 10. So you shift the decimal by 1 place or 1 order of magnitude. Now if you have 130, 130, it will be also 1.3 but times 100. 0.00, and then we want to shift it in. So 1, 2, 2 zeros. So you multiply by 2 zeros. Now let's look at 13000. So it is also 1.3, but you need to multiply by 10, 100, 1000, 10,000. So it's 1, 2, 3, 4. So times 10 to the power of 4. This is in standard form. This one, you have to write it as 1.3 times 10 to the power of 2. So for some numbers, it is used so commonly that we actually create prefixes or names for them. If you were to look at this area, you can see that you're quite familiar with this area. This is the ones place, so there are no prefixes. And if there are 3 zeros, you call it 1,000. So 1, 2, and then 3 zeros. This is 12,000. And then if there are 6 zeros, it's a million. 9 zeros is a billion. 12 zeros is a trillion. So it's all in multiples of 3. So if there are 2 zeros in front of the decimal place, or there are 3 digits behind the decimal place, 1, 2, 3, this is the 1000th position. Or if there are 6 digits behind the decimal place, this is the millionth position. Mathematically, there are symbols for this. We usually call the natural unit the SI unit. SI unit. And for example, the SI unit for length is in meters, m. And if you have 1,000 meters, you can call it 1,000 meters, but it's probably easier if we call it 1 kilometer, or also known as 1 times 10 to the power of 3 meters. So it's the same thing for a million meters. So 1 million meters. Now 1 million meters is a megameter. Now usually we don't usually call this a megameter, but you can write it as 1 times 10 to the power of 6 meters. Or if you have 0.001 meter, this is known as a millimeter. So it's 1 millimeter, or also known as 1 times 10 to the power of minus 3 meters. So on and so forth. We can have micrometers, nanometers, picometers, so on and so forth. So we have some other units like for time, like for second. So 1 second is the SI unit, or second is the SI unit. And if you have 0.001 second, we give it a name. It's called a millisecond. Or if you have 0.000001 second, it is called a microsecond. Or you can rewrite it to be also equals to 1 times 10 to the power 6 seconds. So you can see that this standard form is really convenient. So all these standard forms are really convenient when you want to compare between two very large or very small numbers. If you are asked to solve 1.14 times 10 to the power 5 times 4.56 times 10 to the power 4, now how exactly do you do this? Now it would be really silly for you to write 1, 1, 4, 0, 0, how many zeros are there? 1, 2, 3, 4, 5 times 4, 5, 6, 0, 0. So these are big numbers, right? So this is a negative example. Don't do that. Your calculators may not even have enough zeros. So let's rewrite this. So let's calculate this by just pressing your calculator. Press 1.14 times 4.56. So if I write it down, it will look like that. Now, if this is algebra, you can see that these are cumulative, right? So for example, if this is A, this is B times C and D. So A times B times C times D is the same as A times C times B times D, right? You can reorder them, and that's exactly what we are doing. We are reordering them. So times 10 to the power 5 times 10 to the power 4. So this one, you have to press the calculator. So you will get 5.1984 and then times 10 to the power of 4 plus 5, which is 9. So if you are sharp, you will remember that I am using this rule. AM times AN equals to AM plus N. So 10 to the power of 9, because 9 is 4 plus 5. So that's it. That's your answer. Let's do another one. 1.14 times 10 to the power of 5 plus 4.56 times 10 to the power of 4. Now addition and subtraction is always more difficult than multiplication. So we want to factorize out a common factor over here. For all algebra questions, you always want to factorize out something common. So now these numbers are difficult to factorize. Okay, the easiest way is to look at 10, because you know that you can factorize out 10. If I were to factorize out 10, I will have 10 to the power of 4 here, 10 to the power of 3 here. But there are even more common factors. So you can see that the common factor between, or the largest common factor between this number and this number is 10 to the power of 4. So if I were to factorize out 10 to the power of 4, I'll be left with 1.14 times 10 plus 4.56. So let's examine this. If I were to multiply this back in, if I were to verify, I have to multiply in this manner because there's addition here. 10 times 10 to the power of 4 will give me back this. And then 4.56 multiplied by 10 to the power of 4 will give me this term. So I can work out the things in the bracket. So 1.14 times 10 is 11.4 plus 4.56. And then you can press your calculator. 15.96. So you have this 15.96 times 10 to the power of 4. Unfortunately, this is not the standard form because the number cannot be greater than 10. So we have to shift the decimal place or to convert it into the standard form. So we will write 1.596 times 10 to the power of something. So you have to think, what is here? So to get back this number, something larger, you will have to have one more place than 4, which is 5.